everyone. Today we are discussing very important chapter in competitive purpose, NEET, JEE Mains as well as EAPCET. That is chapter is chemical kinetics. In this chapter, weightage is in per NEET purpose 2 to 3 questions coming from 2 to 3 in this chapter, and JEE Mains weightage is 1 to 2, and EAPCET also 2, and EAPCET weightage also 1 to 2 for maximum 2 questions from this chapter. In this chapter, chemical kinetics. The chemical kinetics mainly deals with rate of reaction. Mainly deals with rate of reaction. Rate of reaction. And the rate of reaction explains only moderate reactions, not fast reactions and very slow reactions. There are types of reactions. How many types of reactions? Types of reactions are variable three. What are the three? First one, slow reactions. Slow reactions. Second one, moderate reaction. Moderate reaction. Moderate reaction. And third one is fast reactions. Definitely reactions are three types. One is a slow reaction, moderate reaction, fast reaction. First of all, what is the difference in slow reactions? In slow reaction, this reaction can proceed with long time. Long time. And moderate reaction can proceed with measurable time. Measurable time. And fast reaction with this reaction proceed with fraction of seconds. Fraction of second. Then the reaction slow reaction is very long time. Then example for slow reactions. Rusting of iron. Rusting of iron. Rusting of iron. Iron is slow. And the alpha sulfur is converted into beta sulfur. Alpha sulfur is converted into beta sulfur. And graphite is converted into diamond. Graphite is converted into diamond. And these all are very slow reactions. That then moderate reactions. These reactions are can measure one time. There is no time calculated. But in the slow reactions, very slow, long time. We are not consider rate. And the reaction rate of reaction we could not explain. And moderate reactions, example for sucrose dissolved in water. Sucrose dissolved in water. Sucrose dissolved in water. For example, we dissolve in sucrose. What is the formula of sucrose? C12, H22, O level. Dissolved in water, H2O. To form glucose plus fructose. Glucose plus fructose. In this moderate reaction, we are measuring time. In the type of sucrose and dissolved in water, we are calculating the rate of reaction. But very fast reactions, it is completed in fraction of seconds. For example, all acid-base reactions. And precipitation reactions also. Precipitation reactions. For example, acid-base reaction. What are acid-base reaction? the acid base reactions are strong acid reacts with strong base. For example, HCl reacts with NaOH, can produce NaCl plus water. It is very fast reaction. Then in this fast reaction, we are not calculating rate of reaction. Then in this reaction, in these three reactions, only the measurable time only in order of reaction. That's why the chemical kinetics explain only in order of reaction. Does not explain rate of slow reactions and fast reactions. So the moderate reaction can explain rate of reaction. What is the rate of reaction? What is the rate of reaction? For example, the rate A plus B is converted into product. A plus B is converted into product. Then the rate depends upon the rate of reaction equal to the decreasing concentration of reactant. Take for example, the reaction rate, reactants are decreases, and whenever reaction proceeds, the reactant concentration decreases and concentration of product increases. For example, A plus B is gives rise to C plus D. In this reaction, A and B are reactants. A and B are reactants, and C and D are products. C and D are products. In this reactants, A and B, the rate of A and B decreases, C and D increases. It means the rate of reaction, the reactant's concentration decreases and product concentration increases. Therefore, they define the rate of reaction equal to decreasing concentration of reactant, decrease in concentration of reactants, concentration of reactant given time or the rate of reaction equal to increasing concentration of product, increasing concentration of product in given time. The reactant, the rate of reaction is defined as decreasing concentration of reactant in given time as well as the increasing concentration of product in given time. Therefore, the overall rate of reaction equal to decreasing concentration of reactant or increasing concentration of product per unit time. Therefore, the rate of reaction equal to dx by dt. What is dx? dx equal to reactant concentration and product concentration difference. Okay. Then, for example, Then, for example, given reaction, rate of reaction, rate representation equal to rate representation. The concentration of reactant decreases. That means negative term of dA by dt equal to this minus d of d by dt. Because of the negative term, because of the A and B are reactants, the concentration of reactant decreases. That's why negative term. And the concentration of d of C by dt equal to plus d of d by dt. These all reactants and products of equilibrium. Why? Because whenever how much percentage decreases, the percentage decreases of reactants is equal to increased percentage increases of products. Then how much percentage? The percentage reactants are decreasing below, same as well as equal percentage ratio increases of products. That's why we are writing equilibrium with all reactions. Okay. For example, we are in same reaction, ammonia formulation N2 plus 3H2 is gives rise to 2 moles of NH3. Then the rate representation equal to rate representation. The N2 and H2 are reactants. That means the reactant concentration decreases d of N2 by minus d of N2 by dt. In stoichiometric coefficient 3, 1 by 3 equal to minus 1 by 3 d of H2 by dt. Then the ammonia is a product. The product concentration means what? The reactant concentration is decreases and product concentration is increases. Then reactants are negative side. Then product is a positive side. 1 by 2 into d of NH3 by dt. This is the rate representation. In this rate representation, all reactants and products are in equilibrium. For example, in this problem, the rate of N2 equal to 2 into 10 to the power of minus 6, and then calculate NH3 and N2 concentration. This means the reactant of concentration N2 equal to the NH3. Therefore, what is the relation? The d of N2 by dt equal to 1 minus 1 by 3 into d of H2 by dt. Then we are calculating H2. We are calculating H2 value. Therefore, minus d of H2 by dt equal to. Then in this 3 is denominator. Then multiply it 3 factor. Therefore, minus 3 into d of N2 by d of N2 by dt. What is the given value? The N2 value equal to minus d of H2 by dt equal to the N2 value of 3 into what is the value given? So into 10 to the power of minus 3. Therefore, rate of H2 equal to minus d of H2 by dt equal to 6 into 10 to the power of minus 3. This is the calculation of rate of reaction in N2. In this problem, N2 is given. They calculate NH3 and H2. This is the H2 form. Then next, the N2 based on calculate H2 is what is the d of H2 by dt equal to 6 into 10 to the power of minus 3. Then calculate ammonia. What is the relationship of N2 and ammonia? Then d of minus d of N2 by dt equal to what? 1 by 2 positive term 1 by 2 into d of NH3 by dt. Then you want d of NH3 ammonia concentration 1 by 2 into d of NH3 by dt equal to minus d of N2 by dt. Then we want only ammonia concentration NH3 by dt equal to this type side 2 is a denominator of this product side 2 into minus d of N2 by dt. What is the given value N2? The N2 value is given 2 into 10 to the power of minus 3. Substitute N2 value, then d of NH3 by dt equal to 2 into and what the value of N2? 2 into 10 to the power of minus 3. Therefore, the d of NH3 by dt equal to 4 into 10 to the power of minus 3. In this method, the calculation of rate. Why? Because in this reaction, the concentration of reactant, how much percentage decreases, and the equal percentage of increases. That's why we are writing equilibrium. That's why the N2 and H2 equilibrium and equal, and the N2 and ammonia equal to calculate this type of rate of reaction. And the rate of reaction mainly depends upon concentration of reactant only. For example, therefore the rate of reaction mainly depends on concentration of reactants. For example, A plus B gives rise to product. The rate depends upon only reactant A and B. Then rate equal to the relation is breaking. Then one constant is developed K into A into B. What is the K? The K equal to rate constant. K means rate constant. When the concentration of reactants are unity, then that time the rate equal to rate constant. For example, the A and B are equal concentration in one. Therefore, the rate equal to K into A into B. Then rate equal to K into the concentration of unity. The concentration is unity. That means A value given 1, B value 1. In this case, therefore, the rate equal to rate constant K. Therefore, the rate of the rate equal to rate constant. Therefore, units. What are the units of rate constant? The rate constant is also depends upon reactants. That's why reactants, the rate constant units equal to moles per liter, concentration moles per liter per time. That means what is the dx by dt? That's why dx means concentration of reactant moles per liter and time taken. Therefore, the units of rate constant equal to units of rate constant equal to moles per liter and per time. And this is also in explaining nth order of reaction rate. Reaction rate equal to nth reaction order of reaction rate equal to moles per liter whole power minus n per time. In this is the nth order of reaction. For example, we want zero order reaction. N equal to 0 means zero order reaction. Zero order reaction. It's equal to. In this zero order n equal to 0, substitute in this nth order of reaction. Nth order of reaction. This is very important. So many times asking in units. Then zero order reaction, what are the units? We are substituting n equal to 0 in this nth order reaction. That means moles per liter and 1 minus n equal to what? N equal to 0 per time. Per time. 1 minus 0. 1 minus 0 means 1. Therefore, the units of zero order reaction moles per liter 1 per time. Therefore, the zero order of reaction units equal to units of zero order reaction equal to moles per liter and per time. The zero order reaction is similar to that of rate constant. Therefore, the zero order reaction of rate units is similar to rate constant. K. Okay. Then this is the zero order reaction. Then, for example, n equal to first order. What is the units of first order reaction? N equal to first order reaction means n equal to 1. First order reaction means n equal to 1. Substitute in nth order units. What are the nth order? Nth order units. Nth order equal to moles per liter and 1 minus n per time. In this n equal to 1, first order n equal to 1 means substitute the nth order reaction n equal to 1 means moles per liter inverse and 1 minus 1 and time. The 1 minus 1 means 0. That is total order of units moles per liter inverse 1 minus 1 means 0 per time. Therefore, the units of zero order reaction, units of first order reaction is only time inverse. This is the first order reaction. Therefore, we have to take second order reaction. What is the second order? Second order means n equal to 2. N equal to substitution in this nth order reaction. The n equal to 2 means second order reaction. Therefore, nth order units are n equal to 2. Substitution in nth order units. What are the nth order equal to? Moles liter inverse 1 minus n per time. Therefore, n equal to 2. Substitution in this nth order units are moles liter inverse and 1 minus 2 per time. The 1 minus 2 means minus 1. Therefore, moles liter inverse minus 1 time inverse. Therefore, what is it? Minus 1 means, therefore, for moles and minus 1 get false liter and time inverse. Therefore, the the second order reaction units equal to second order reaction units equal to given equal to per moles, liter and time liters. This is the calculation of order of reactions and units and rate of reaction. Next, what is the order of reactions? Order of reaction. Order of reaction. The order of reaction is the sum of powers of concentration terms in rate of. The sum of powers of concentration terms in rate law. Okay, in rate of reactions, for example, rate law is depends on only reaction. Rate law depends on reactions. For example, the rate law is depends upon only reactant. It means the rate law depends upon only reactant. Then rate equal to what? The rate equal to K into A into B. What is the order? Therefore, the order of reaction. Order means some powers or sum of the powers. What are the powers of A and B? This is power 1, this is power 1. Therefore, the order equal to 2. In some reactions, the order is maybe negative and fractions also. The order of reaction is maybe negative and fractions also. For example, they are calculating mathematical representation of zero order reaction. The mathematical representation is the reactants are converted into products. That means the rate is inversely proportional to directly proportional to only reactants. The zero order means the reactant power is 0. Then the rate equal to the constant K power R power 0. Then what is the rate? The rate is reactant means minus V of R by dt equal to K into R power 0. The R power 0 minus V of R by dt equal to R power 0 means 1, K into 1. Then minus V of R by dt equal to K. Therefore, the minus V of R equal to K into dt. This is the trigonometry. Then what we multiply with C. Therefore, we want D of R equal to minus K into dt. Integration on both sides. Integration on both sides. Where integration on D of R equal to minus K integration on dt. The integration and differentiation, the integration of dr equal to R equal to minus K into dt. Plus constant. This is the equation 1. If R equal to R0 and T equal to 0, substitution in equation 1. Therefore, substitute the equation 1. If R equal to 1, R equal to R0. Then minus K into T value is 0 plus constant I. Therefore, K into 0 means R0 equal to I. This value I equal to what? R0. This value substitution in equation 1. Equation of substitute this value, constant value is R0. Substitution in equation 1. What is the equation 1? The equation 1, R equal to minus K of T plus I. The constant value I is R0. Substitute the equation R equal to minus K of T plus R0. We want rate constant. Therefore, R minus R0 equal to minus KT. Therefore, minus KT equal to R minus R0. We want only positive term. The KT equal to R0 minus R. We want in this term. We want one term. For example, R minus R0 equal to minus KT. This is as similar to like y equal to minus mx plus c. Then the graph equal to y means r rate versus t. There is negative slope. Slope equal to minus k. Then the final reaction K equal to R0 minus R by T. Then equal to K equal to 1 by T into R0 minus R. In this R0 is initial concentration. Then R is final. If R equal to R0 equal to initial concentration. And R equal to final concentration. If in the above equation, what is the equation? K equal to 1 by T into R minus R0 minus R. If initial concentration R0 equal to A and final initial concentration. And R equal to A minus X is final concentration. Substitution in above equation. That means K equal to 1 by T into R value, R0 value is A minus R value is A minus X. Therefore, K equal to 1 by T into A minus A plus X. This A is cancelled. Therefore, K equal to X by T. Therefore, the X equal to KT. These are the these two are zero order reactions. Okay. Therefore, the X equal to KT. This is similar to like Y equal to MX. MX means this is the graph. So the what is the X value? X equal to T, Y equal to X equal to KT, X equal to T and Y equal to X. And Y coordinate is X. X equal to what? X equal to R0 minus R. R0 minus R. Then graph is Y equal to MX means through the origin. This is the zero order reaction and graphs. This graph relation also very important. This reaction. Then next we are calculating the equation for half-life. What is the half-life? Half-life means the reaction completed only 50%. The reaction completed only 50%. Half-life. What is the half-life reaction? The half-life means half-life Half-life means the reaction completed 50% only. 50% of reaction completion. Of reaction completion. Completion means the T initial time equal to T. Initial time equal to T. Then half-life means half-life T equal to T of and concentration equal to R naught by 2. Take it. Therefore, zero order reaction. What is the zero order reaction? K equal to 1 by T. K equal to 1 by T. 1 by T and R naught minus R. If the T equal to T of and R equal to R naught by 2, substitution in above equation. Then, therefore, the K equal to 1 by T means what? T equal to T of. That means 50% reaction is completed. T equal to T of. That is T of. And R naught minus R equal to what? R naught by 2. R naught by 2. Therefore, K equal to 1 by T of R naught 2 R naught minus R naught by 2. Therefore, the final reaction K equal to 1 by T of into 2 R naught minus R naught means R naught by 2. R naught by 2. We want T of, therefore T of equal to 1 by K into R naught by 2. Therefore, finally, T of equal to R naught by 2K. What is the R naught? T of equal to R naught equal to what? A. That means T of equal to A by 2K. This is it. T of, they are directly proportional to concentration A. Then T of time increases. T of increases. The concentration also increases. Okay, this is the very important relation for zero order reaction. Therefore, what are the units? Therefore, units of zero order reaction. What is the nth order reaction? Nth order units equal to moles, liter inverse 1 minus n time inverse. We substitute in zero order. That means n equal to 0. What is the zero order reaction? 6. Therefore, n equal to 0, zero order equal to zero order units equal to zero order units equal to moles, liter inverse 1 minus n means n equal to 0 and time inverse. 1 minus 0 means 1. Therefore, units are moles, liter inverse and time inverse. This is the zero order of reaction of life and units. For example, examples of zero order reaction. Examples of zero order reaction. Zero order reaction. The decomposition of ammonia. Decomposition of ammonia and HN. Both are example of zero order reaction. Examples of zero order reaction. Zero order reaction. Then first example, decomposition of ammonia. The NH3 2 moles of ammonia. The decomposition will N2 plus 3 moles of H2. It is an example of 0 order reaction. Then second one also decomposition of HI. 2HI is converted into H2 plus I2. These are the examples of 0 order reaction. 0 order reaction. And therefore, all photochemical reactions also. All photochemical reactions. Photochemical reactions are examples for 0 order reaction. 0 order reaction. 0 order reaction. For example, what are the photochemical reaction? HCl H2 plus Cl2 is converted into 2HCl. This is a photochemical means H2 condition. 2HCl. Pick for identification of order of reaction. Identification of order of reaction. Order of reaction. What are the treats? This treat means of life. The concentration, the T of is inversely proportional to 1 by into the power of n minus 1. This n beyond, therefore the n value is 0 substrate. The concentration T of is directly proportional, inversely proportional to n value. What is n value? 0 order. That means 0 minus 1. Therefore, T of directly proportional to 1, a power of minus 1. Minus 1 means therefore the T of is directly proportional to A. Therefore, the concentration increases with time. That is 0 order reaction. 0 order reaction. And we want calculate the reaction n equal to first substitute first order reaction. What is the relation concentration versus time? That means in the half-life is what? T of is inversely proportional to 1 to the power of n minus 1. The first order is n equal to 1 substitute. This T of n equal to what? 1. 1 minus 1 means 0. Then T of is inversely proportional to a power of 0. This means therefore the first order reaction does not depends on concentration of reaction. That means it is a independent of reaction. Independent. Then whenever n equal to second order, n equal to 2, substituting in that reaction T of 1 by a power of n minus 1. This n equal to what? Second order means substituting n equal to 2, a power of 2 minus 1. 2 minus 1 means the T of is inversely proportional to concentration. Then observe the difference. The 0 order reaction is concentration increases with time. Then first order is independent of concentration and second order is inversely proportional. For example, the concentration and time given. Then calculate. For example, the concentration is 0.4 for 10 minutes. And 0.6 moles for 20 minutes. What is the order of reaction? First of all, I observe the identification relation. What is the relation? The concentration increases. Concentration increases. Then time also increases. That means the T of is directly proportional to a which order reaction? 0 order reaction. Therefore, this is a order equal to 0. Order equal to 0. Then, next example of problem. For example, the concentration is given 0.4 moles and 0.6 moles. And the time given 10 minutes and 10 minutes. Observe this relation. Both the concentration increases, but the time is not increases. That means independent of time. That means the order equal to independent of concentration is first order reaction. Therefore, order equal to 1. Then finally, last one, the second order relation. What is the second order relation? The second order relation, for example, the 0.8 moles concentration and 0.4, and the time is 5 minutes and 10 minutes. In this relation, the concentration increases, concentration decreases, but time increases. Therefore, the relation is T of is inversely proportional to A. This is observed in second order reaction. Second order reaction. Therefore, the order equal to